All right, let's do another example of graphing a quadratic that's not quite in vertex form. Maybe it's given to us in standard form, like this one is. Example number 2 gives us that g of x is equal to 3x squared plus 12x plus 13. And I know by just looking at the equation that it's going to be a parabola because it's a quadratic. It has that x squared, right? And I know that the parabola is going to open up and be kind of skinny because of that leading coefficient, the a value there. So I know that I'm going to be skinny, I'm going to open up, and I'm going to be a parabola. The problem is that's all I know, with just the information they give us in standard form. But if I can make this look like vertex form, then I'll be able to figure out exactly how to shift this parabola. I can find a couple other ordered pairs on my parabola, and then I can graph it exactly. So let's go ahead and do the process of completing the square. The problem is, when we're doing completing the square, we normally have no number in front, or really there's an invisible 1, right? And so on this problem, because there's that 3, what we need to do first before we do anything is actually get rid of the 3 for a second. So in order to do that and do it legally, mathematically, what we're going to do is we're going to go through and divide every single term by 3. As long as I do it to every single term, my equation should still be balanced, right? So I'm going to take 3 and divide it by 3. That gives me a 1x squared. I'm going to take 12 divided by 3. That's a 4x. And then I have my 13 over 3. Doesn't quite divide evenly on that piece, but that's okay. Now remember, when I'm completing the square, I want to keep all of my variable terms on the left side, and I want to move everything without a variable to the right side. So that's why my 13 over 3 is now negative, because I subtracted it over. Now we've got to figure out what number to add to both sides of this equation so that I can factor that left side into a perfect square. So let's use our trick. We can take the number in front of x, which is 4, divide it by 2, which is 2, square it, and add that number to both sides. So 2 squared is 4, and so I'm going to add 4 to both sides of my equation. That allows me to factor the left side. Numbers that multiply to 4 that add to 4 are x plus 2 and x plus 2, or I can say x plus 2 squared, right? Now on the other side, the right side, I have a fraction and I need to add 4 to it. So I really have 2 fractions if you want to think of it that way. And anytime I'm adding fractions, remember we need a common denominator. So it looks like I'm going to need to multiply this second fraction, numerator and denominator, by 3 so that I can get a common denominator. When I do that, I have a negative 13 over 3 plus 12 over 3, which really gives me a negative 1 over 3. Now we have to be careful though, because we're not quite back to the original form of my problem. Remember when we started, we said that this parabola had an a value of 3? It was going to open up and be skinny. Well, if we end, we have to still have that same a value. And do you remember we went through and divided everything by 3? Well, we actually have to bring that 3 back this time. And so we went through and divided by 3. But if we want to bring that 3 back, what we need to do is go through and multiply by 3 so that that leading coefficient, the a, is still a 3. But I can't just multiply the left side by 3. I have to also multiply the right side by 3 so that I can keep my equation balanced. You notice on the right side that the 3's reduce each other, and so I end up with just a negative 1 on that side. So now I have a quadratic that has the 3, the leading coefficient that I need. I have my x plus 2 squared equal to negative 1. This almost looks like quadratic form, but I need to move everything to the same side first. So I'm going to take that negative 1, I'm going to add it to both sides, and so hopefully it looks like vertex form now, where I have a leading coefficient of 3, which is perfect, and I should be able to pick out my vertex. Now that it's in vertex form, if I look at this equation, what is my vertex? Well, it looks like my vertex is the point negative 2, 1. If my vertex is the point negative 2, 1, I know that I'm going to shift it to the left 2. I'm going to go up 1, and so I at least have 1 point, right? I have left 2, up 1. My vertex is right there. Remember, I knew I was going to open up and be skinny, but let's go ahead and find 2 more points so I can graph this a little more efficiently. So here we go. I'm going to pick a number just to the left of 2. I'm going to pick a number just to the right of 2, and I'm going to plug it into my equation. I plugged in negative 1. I have negative 1 plus 2 is 1. 1 squared is 1. 1 times 3 is 3, and 3 plus 1 is 4. If I do the same thing with a negative 3, if I substitute in a negative 3 into my equation. If I plug in a negative 3 for x, negative 3 plus 2 is negative 1. Negative 1 squared is 1. 1 times 3 is 3, and 3 plus 1 is 4. So now I have 2 other points, 3 total, so I can graph this a little better than just kind of guessing what it looks like. I have a point at negative 1, comma 4, negative 1, 4. I have my vertex, which is at negative 2, 1. And I have another point at negative 3, comma 4. Remember, this parabola was supposed to open up and be skinny, and isn't that the case? Opens up, is skinny. I know exactly where the vertex is and what it looks like now. I know that there's an axis of symmetry, a mirroring line that kind of cuts it exactly in half, where the left side is a mirror of the right side. And that axis of symmetry is the vertical line, x equals negative 2. But you see, that one's a little bit harder because we have to do a few more things in order to get it to be vertex form. Let's do one more that's also going to be a little bit tricky if I have to complete this square and get it to look like vertex form. And then I'm going to show you a cool trick. All right, example number 3 gives us an f of x, which is negative 2 x squared plus 10x minus 7. We want to find the maximum or minimum value. So really, we want to figure out where the vertex is, right? Now, the problem is my equation isn't given to us in vertex form, so I don't know what the vertex is yet until I get it to look like vertex form. I do know that it's going to be a parabola though because of the x squared, and I know that the parabola is actually going to open down and be kind of skinny, right? Because that leading coefficient, my a, is a negative 2, so I know that it's actually going to have a maximum, right? Because it's going to open down. I just don't know where that maximum is going to be at yet. So what we have to do is do the process of completing the square. But just like we did in example number 2, we can't have a leading coefficient other than 1. So how did we get rid of the 3 last time? Well, let's get rid of the negative 2 the same way. Let's go through and divide every single term by negative 2. That'll give me a new equation. I have a x squared, positive. I have a minus 5x, and then I have a positive 7 over 2, because these two negatives make a positive. Now you noticed I also moved it over to the other side by subtracting it. And so now I have an equation that gives us an x squared minus 5x that's equal to a negative 7 halves. The two negatives made a positive, but then I subtracted it over to the other side. Okay, now we have to go through and figure out what number to add to both sides so I can factor that left side into a perfect square. Let's take the number in front of x, which is negative 5. Let's divide it by 2. That's negative 5 divided by 2. Then I have to go through and square it, and that's the number I'm going to add to both sides. Ooh, a little bit tricky this time because we have fractions, right? So if I take negative 5, divide it by 2, and then square it, negative 5 over 2 times another negative 5 over 2 is a positive 25 over 4. So that's the number I'm going to add to both sides. You can already see that this one's going to get a little bit ugly because we've got lots of different fractions. But the only way right now for us to figure out where that vertex is, where that maximum is to make it look like vertex form. All right, so let's keep going. When we add that 25 over 4 to both sides, that should allow our left side to factor into a perfect square. We need to figure out what numbers multiply to 25 over 4, that when I add them together, I get negative 5. Do you remember the trick? Remember that's always the number that we took when we divided that coefficient of x by 2? So it's really going to be a negative 5 halves. It's going to be an x minus 5 halves times another x minus 5 halves, or I should be able to say x minus 5 halves squared, right? That's the whole point, being able to write it as a quantity squared. So then on my right side, if I'm trying to add these two fractions together, I need to make sure that I have a common denominator. So let's multiply this first one by 2 on the numerator and denominator so that I can have a common denominator of 4. So I end up with the negative 14 over 4 plus 25 over 4, which really gives me 11 over 4. But remember, this almost looks like not quadratic form, but vertex form. However, my a at the beginning, this negative 2, should be the same a in the end. So I should still have the same leading coefficient. There should be a negative 2 in front of my quadratic equation, whether it's in standard form or vertex form. So we need to bring back that negative 2. So let's multiply both sides by negative 2. You notice on the right side, I end up getting a negative 22 over 4, and that actually reduces to a negative 11 over 2. All right, I'm going to go ahead and move everything to the same side by adding the 11 over 2 over. And so I have a new function, same as the original function, just in vertex form, that looks like this. All right, what is the vertex then? Well, my vertex is the point 5 halves, comma 11 halves, right? You could put it into a table of values. You can pick a number just before it, you can pick a number just after it, and you should be able to plot those. It's a little bit ugly because you're going to have to kind of estimate where 5 halves is and 11 halves is, but you could graph it if you needed to. Now the question really just asks us to find the minimum or maximum value. Remember, this parabola is going to open down because that leading coefficient is negative. And so if we wanted to find the maximum value here, remember that maximum value is really our y value of our vertex. So our maximum here is going to be y equals 11 halves. We have the vertex at 5 halves, comma 11 halves, and our maximum is going to be that y value of 11 halves. But that was kind of ugly, can I say? Right? Because of all of those fractions and being able to complete the square with all of that. So I wonder if there's an easier way that we can find the vertex and graph if it's not in vertex form and completing the square doesn't work out so cute.